Here on my off-grid property, there is no utilities for miles. So to run my power tools, I'm actually using solar power from my van. Here's how. 4 200-watt solar panels are attached to the top of the van for 800 watts total. We connected all the solar panels by using these 4-in-1 branch connectors. We connected all 4 of the panel's negative lines to these right here, and it leads it to one line. And then we also did the same for the positive lines as well. The only difference is we connected these inline fuses to all the positive lines before we connected them to the 4-in-1 branch connectors. Then we took the positive and negative wire from our solar panels and ran them through this cable entry gland. Then we drilled holes in the van, ran the cables through, and then we sealed it up with butyl sealing tape. This makes it waterproof. Here you can see the positive and negative wire from our solar panels coming in from the roof. Next, we need a solid place to attach our solar components to, so we're going to use this 3/4 inch thick board and attach it to the wall of the van. To do that, we're going to remove these plastic plugs right here, and it's easy to do. Just take 2 flathead screwdrivers and pull the pins right out. Now when you peel back the plastic, you can see the existing holes that we're going to attach the plus nuts to. It's easy to do. Just add a 1/4 nut to the tip of your tool, insert it in the hole, and then squeeze the handles. Then you unscrew the mandrel and you have a nut already in the wall. You can see we have 4 plus nuts, one here, 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 and here. With the board bolted to the van, we can now add our Renogy Rover 60 amp NPPT solar charge controller, Blue C 12 volt fuse box, and 3000 watt pure sine inverter. We built a box for the batteries out of thick plywood and 2x3s to prevent the batteries from sliding around, and we used corner braces to attach it to the wall. Then we put our 2 batteries in place. Here's how we connected everything together. Everything's connected. Here we have our 4 solar watt panels going into our inline fuse to our 4-to-1 branch connectors, and these are the lines coming into the van. Don't connect them to your solar charge controller yet. You'll fry your system. You need to connect your batteries and everything else first, and then connect these lines last. So here we have the solar charge controller, we have the inverter, the 12 volt fuse box, and we have our batteries. Now to protect the system, we need to actually add a couple circuit breakers in there. So the first circuit breaker is connected here, and it's based off of the solar charge controller. This is 60 amps, so we need at least a 60 amp circuit breaker. But we're actually going to multiply that 60 amp by 1.25 for a margin of safety, and that would give us 75. So we actually have an 80 amp circuit breaker here. Then we continue down the positive line into our inverter. Then our next positive line comes off of our inverter and goes into our next circuit breaker. We determine the size of this based on our inverter. We have 3000 watts here at 12 volts. So you divide 3000 watts divided by 12 volts, that would give you 250 amps. So you have to have a minimum of 250 amp circuit breaker here. If we multiply that by 1.25 for our margin of safety, that would give us 312.5 amps. So I only have a 250 amp. It hasn't popped yet, but if it does pop, I would actually upgrade this to a 300 amp circuit breaker. So off of that, you can see we run our positive line to our fuse box, and then we, on the opposite side of the circuit breaker, we run a positive line to our batteries, which are wired in parallel. The negative line's a little bit easier. You don't have to add circuit breakers on them. We just run the negative line from our solar charge controller to our inverter, another negative line from the inverter to the 12 volt fuse box, and then another negative line from the inverter to our batteries. Take this out, and you can see here PV is for the solar panels. So you have your positive going in and you have your negative going in, and then over here you can see it says battery, positive, and your negative. Positive what goes down around into our circuit breaker. It's an 80 amp circuit breaker for our 60 amp charge controller, and then it goes down into our inverter. From our inverter, the positive wire continues up to our 250 amp circuit breaker, and then 2 positives go to our blue C fuse box. So we'll go ahead and take this off, and what you can see here is from the circuit breaker we have a positive going up, and then we have another positive going up. The reason why it has 2 positives, one of them is for appliances that you keep on all the time, such as your refrigerator, and then the other one is for items that you turn on and off, such as your LED lights and your fans. Then on the opposite side of our circuit breaker we have our positive that comes down into our batteries. Negative from the solar charge controller comes down and it goes to the inverter. Also, we have a negative line going from the inverter to our fuse block. Our last negative line runs from our inverter and it comes around and it goes to our battery. We use the positive terminal of this battery to connect to our system, and then we use the negative terminal of the other battery to connect to the system. When you put 2 batteries in parallel, it's going to increase your amp hours. So we'll have 412 amp hours, but the voltage will stay the same. If we connected the positive terminal to the negative terminal of the other battery, we would be running it in series, and the amp hours would be the same, but it would increase it to 24 volts. We don't want that. Everything on our system here runs off 12 volts and has the fuses here and a fuse puller. So now let's go ahead and show you how the AC power works. We have 3000 watt continuous inverter. Here are the plugs on the side. You can see the 2 yellow ones are the ones that we made to make our AC outlets. The gray one is for the hot water heater. And here in the back of the van you can see one of our AC outlets, and then we also have another AC outlet up front where we plug our laptops and everything else into. All right, and what I really like about the Renogy Rover is you can plug in here this BT1 right here. That works off of Bluetooth, and we can download the Renogy app and we can see everything on our phone that's going on back here. So we don't have to crawl underneath our bed to get our readings. So you can see we have the watts coming in, the amps, and you got your state of charge, and it gives you all this information here, even the battery type that you're using, the current, the voltage, the power, the temperature, settings where you can come set your voltage, your battery type, and it also includes a history, the charging amp hours, how many times it's over discharge, full charge. Really love the BT1. The app allows me to check everything on my batteries without actually having to go to the system. And to protect the wires, I went ahead and screwed a board into the battery box, and then used Velcro on top and attached another piece of wood, and then I used Velcro on some plexiglass to cover up the wires. Left both sides open so the system could breathe. I did not include the size of the wires that I used because your system might be different depending on how long your wires are and how much power you're putting through it. So I recommend going online and get a wire sizing chart to help you with the exact size of the wires that you need for your system. Time to get back to work. Thanks for watching.